Welcome back, students. Today we are going to study modern periodic table. According to modern periodic law, the chemical and physical properties of an element is the periodic function of its atomic number. According to modern periodic table, the chemical and physical properties of an element is the periodic function of their atomic number. But what is atomic number? The number of protons present in an atom is called atomic number. An atom is electrically neutral. Hi dear student, we are studying modern periodic table. According to modern periodic law, the properties of element are the periodic function of their atomic number. But what is atomic number? The number of proton present in an atom is called as atomic number. An atom is electrically neutral and therefore the number of proton and the number of electrons are equal. But atomic number and the number of electrons are related to electronic configuration. But what is electronic configuration? electronic configuration. The arrangement of electrons in an atom in different shells is called electronic configuration, and the formula of distribution of electron in different energy shell is 2n square, where n is number of shell. One square is 1, 1 into 2 is 2. 2 square is 4, 4 twos are 8. 3 square is 9, 9 twos are. According to the formula 2n square, the distribution of electron is, in first orbit there will be 2 electrons. In the second orbit there will be 8 electrons. In the third orbit there will be 18 electrons. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphor, sulfur, chlorine, argon, potassium, calcium. They have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 atomic number respectively. Now we will see their electronic configuration by the formula 2n square. The first orbit will have one electron. This is the electronic configuration according to the atomic number. Now let us consider hydrogen, lithium and sodium. Let's have brainstorming on hydrogen, lithium and sodium. Hydrogen. Atomic number 1. Number of electron present 1. Lithium. Atomic number 3. Number of electron present 3. And third we will consider sodium. Atomic number 11. Number of electron present 11. the number of electrons present in the outermost shell is called as valence electron. In hydrogen, number of electrons are 1. In lithium, in sodium, in all the three examples which we have taken, we see that number of valence electron, that is the number of electron in the outermost orbit, is 1, 1, 1. So they all belong to group 1. They all belong to group 1. So we have taken three examples: hydrogen, lithium and sodium, and consider their atomic number 1, 3 and 11 respectively. We have arranged the electron according to the electronic configuration and found out that in the outermost orbit of all the three elements, only one electron is present. So number of valence electron is 1, and therefore all the three elements belong to group 1. This all belong to group 1. Number of shell. How many number of shells are there? 1. Number of shell 1 and 2. At the center there is nucleus. Number of shells 3. My dear student, we have done one activity. According to this activity, the number of electrons in the outermost shell gives us group number. All these three elements have only one electron in its outermost shell. So number of valence electron is 1. So these all three belong to group 1. Number of shells in hydrogen is 1. Lithium number of shell is 2, and sodium number of shell is 3. So the number of shell tells us about the period. 1 shell, period 1. 2 shell, period 2. 3 shells, period 3. From this idea, now we can arrange the element in modern periodic table. In modern periodic table, there are 18 groups. and 7 period. We will arrange the element up to period 3. So we will consider the rule. There are 18 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now we have 1 to 20 elements. We know their atomic number. We know the electronic configuration. We know that valence electron, number of valence electrons will tell us group number, and number of shells will tell us period number. Now we will try to arrange them in the table. Hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, calcium 20. Electronic configuration. One, two, one, two. Here we have arranged them according to the brainstorming which we have done. Now, if we have brainstorming on modern periodic table, we see the number of valence electron is 1, 1, 1, 1. So all these elements belong to group 1. These all are what? Groups. Group 1, 2, 3, 4. And these are what? Periods. This is our modern periodic table. My dear student, you must have thought, why did I write elements only up to atomic number 20? Because the arrangement of elements in modern periodic table according to the formula 2n square is only up to 20. So it is up to 20, so we have taken elements up to 20. Find out the rules according to which how the elements were arranged, and we ourselves try to arrange it in a modern periodic table. Now let us have some brainstorming upon the modern periodic table. If you see the modern periodic table, if you see group 1, the number of valence electrons are 1. Group 2, the number of valence electrons are 2. Group 13, the number of valence electrons are 3. Group 14, the number of valence electrons is 4. Group 15, the number of valence electrons is what? 5. Group 16, the number of valence electrons are 6. Group 17, the number of valence electrons are 7. And group 8, the number of valence electrons are not considered, but the complete electronic configuration is considered. So the first orbit electronic configuration is 2, second is 8, and the octet rule is complete. So from this we can say that number of valence electron give us a group number, whereas number of shells, here number of shell is 1, here number of shell is 2, number of shell is 3, number of shell is 4. So if only one shell is there, we can consider it as period 1. If 2 shells are there, we will take it that period 2. 3 shells are there, period 3. 4 shells are there, period 4. From this, what we can write? We can write we can say that the group and period of an element depends upon their electronic configuration. In modern periodic table, there are 18 groups and 7 periods. But what are these group and period? Let's have some brainstorming upon groups and periods. The vertical columns of element in the modern periodic table are called groups. These are the vertical columns of element in modern periodic table, and these are called as groups. The group number tells us the number of electrons present in the outermost shell. For example, number of electrons in the outermost shell 1. So group 1 will have 1 electron in the outermost shell. Group 2 will have 2 electrons in the outermost shell. Group 13 will have 3 electrons in the outermost shell. Group 14 will have 4 electrons in the outermost shell. Group 15 will have 5 electrons in the outermost shell. Group 16 will have 6 electrons in the outermost shell. And group 17 will have 7 electrons in the outermost shell. And group 18 will have the electronic configuration completed, and if we consider the outermost shell, we can consider the outermost shell to be having 0 electrons. The group number tells us about the number of electrons present in the outermost shell of an element. For example, Group 18, number of valence electron 8 or electronic configuration completed. So the group number will tell us the number of valence electron. The same group have the same number of valence electron, therefore they have same chemical properties. 1 1 1, group 1, same group will have same valence electron, same group will have same valence electrons, same group will have same valence electrons, same group will have same valence electrons. Therefore all the elements in the same group will have same chemical properties. The same group have the same number of valence electrons, therefore they have same chemical property. But as we go down or move down in a group, all the elements have same valency. In a group, all the elements will have same valency. You can see from the table. As we move down in a group, atomic radius and atomic size increases. As we move down the group, electropositivity and metallic character goes on increasing. The valency of an element depends upon the number of valence electron of an element. The valency of an element depends upon the number of valence electron of an element. In a group, all the elements have the same number of valence electron. Thus, they have same valency and same chemical properties. Atomic radius and atomic size. The distance between the nucleus and the outermost shell is called atomic radius. It's called atomic radius. As we go, the distance between the nucleus and the outermost shell in called atomic radius as we move down the group. In first element you can see that is group 1, shell is 1. Sorry, as we go down in group 1, in period 1, the element 1 shell, 2 shell, 3 shell, 4 shell. As we move down a group, the number of shells increases, due to which atomic radius increases. As a result, there is also increase in the atomic size of an element. The next topic which we are going to consider is electropositivity and metallic character. Let's have some brainstorming on electropositivity and metallic character. Electropositivity and metallic character. Let's have brainstorming on electropositivity and metallic character. The tendency of an atom to lose an electron and get converted into positive ion is called electropositivity. Electropositivity is a metallic character. While going down a group, the atomic radius and atomic size of an element increases, due to which the nuclear charge goes on decreasing. This increases the tendency of an atom of element. This increases the tendency of an atom of element to lose electron. As a result, the while going down a group, the atomic radius and the atomic size of an element increases, due to which the nuclear charge goes on decreasing. This increases the tendency of an atom of an element to lose the electron. The tendency of an atom to lose the electron increases. It means that it means that the electropositivity and the metallic character of an element increases down a group while going down a group. Moreover, the electron present in the inner shell lies between the valence shell and the nucleus. Means these electrons which lies in the inner shell between the valence electron and nucleus reduce the nuclear force of attraction between the valence electron and the nucleus. That's all, students. We'll stop here, and then next class we will study about period. start some brainstorming on periods of modern periodic table. What are periods? The horizontal rows of elements of modern periodic table are called periods. Again, the horizontal rows of elements of modern periodic tables are called periods. The period number tells us the number of shells present in an atom of an element. Two things we have studied about periods in the modern periodic table. The first thing, the horizontal rows of element in modern periodic table are called periods. Again, the horizontal rows of element of modern periodic tables are called periods. The periods number tells us the number of shells present in an atom of an element. The chemical properties gradually change as we move from left to right in a period. So my dear student, today we are going to study about period of modern periodic table. The first thing, the horizontal rows of elements of modern periodic table are called periods. The period number tells us the number of shells present in an atom of an element. The chemical properties gradually change as we move from left to right in a period. When we are going to study periods, we will always study period from left to right. As we move from left to right in a period, we find that as we move from left to right in a period, we see that the valency varies. It means that the valency goes on changing. First thing. The second thing, again, as we move from left to right in a period, the atomic radius and the atomic size goes on decreasing. It means that atomic radius and atomic size decrease. And the third factor, the electronegativity or non-metallic character goes on increasing as we move from left to right in a period. Now, we will have brainstorming on each and every factor in detail. The first factor which we are going to consider is valency. Valency. Let's have some brainstorming upon valency. The valency of an element depends upon the number of valence electron. While moving from left to right in a period, it means that if we consider the elements from left to right in a period of modern periodic table, then what can we find? The number of valence electron goes on increasing by 1 electron. For example, So if we move from left to right in a period, what can we say? The number of valence electron goes on increasing. For example, if we take lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So number of valence electron goes on increasing. 1, 2, 3, 4, 5, 6, 7, 8. Here we can see that the number of valence electron goes on increasing. If the number of valence electron goes on increasing, then what we can say? The valency goes on changing. So then, what can we write? We can say that as the number of valence electron change, the valency also change in period from left to right. As a result, then we can come to the conclusion that as a result, the chemical properties gradually change from left to right in a modern periodic table. The next factor on which we are going to have brainstorming is atomic radius and atomic size of an element when we move left to right in a period of modern periodic table. Let's have some brainstorming on atomic radius and atomic size. While moving from left to right in a period of modern periodic table, the atomic number goes on increasing by 1 electron. It means that 1 electron goes on increasing and therefore atomic number goes on increasing. If the atomic number goes on increasing, then what will happen? The effective nuclear force of attraction will also goes on increasing by 1 unit. But the number of shells remains the same. Again, while moving from left to right in a period of modern periodic table, we have seen that atomic number goes on increasing. This atomic number goes on increasing by 1 electron, and therefore the nuclear charge also goes on increasing by unit 1. But the number of shells remains the same. If you consider any period from left to right, you will see that atomic number goes on increasing, the number of electron goes on increasing, due to which the nuclear force of attraction also goes on increasing, but the number of shells remains the same. From all these factors, what conclusion can be drawn? Let's find out. Now what will happen? As a result, the effective nuclear force of attraction pulls the valence electron to a greater extent, due to which the atomic, due to which the due to which the atomic radius as well as the atomic size goes on decreasing while moving from left to right in a period of modern periodic table. And the last factor upon which we are going to have brainstorming is electronegativity and non-metallic property. Electronegativity and non-metallic property. Electronegativity. The tendency of an element to gain the electron and get converted into negative ion. Again, the tendency of an atom of an element to gain the electron and get converted into negative ion is called as electronegativity. Electronegativity is a non-metallic property of elements. Let's have some brainstorming on electronegativity and non-metallic character of elements in a modern periodic table when we move in a period from left to right. As we move from left to right in a modern periodic table, the atomic number goes on increasing, due to which the nuclear force of attraction, which is called as the nuclear charge, also goes on increasing, but the number of shells remains the same. Therefore, the tendency of element to lose the electron Therefore, the tendency of an element to lose the electron decrease. Therefore, the tendency of an element to lose the electron decreases. As a result, the electronegativity and non-metallic property of an element increases in a period as we go from left to right in a period. Again, as we move from left to right in a modern periodic table, the atomic number goes on increasing, due to which the nuclear charge also goes on increasing, but the number of shells remain the same. Therefore, the tendency of element to lose the electron decrease. As a result, the electronegativity and non-metallic property of an element increases in a period as we go from left to right in a period. So my dear student, this was the study of modern periodic table. In the next class, we will study a new topic. Thank you very much.